Thank you everyone for being here. My name is Tahreem and I'll formally introduce myself. But I build agents a lot. And one of the challenges is that agents are not very reliable, right? So they have a mind of their own. And that's because that's what agents are. So today I want to talk about the why before we talk about how to do reliability and how to some of the strategies with context engineering to enforce reliability with agents so you can have agents that are more trustworthy. Yeah, I think we're good to start, I think. So, okay. Yeah. Okay, great, wonderful. Here's my introduction. I'm an AI tech lead at a company called Red Buffer. I'm also a speaker. I'm a Google developer expert in AI. And I'm also a senior team lead at Turing College. So we mentor folks who are just starting off in AI. And yeah, but I think at the core, I'm like a software engineer. So that's like a quick introduction about me. The way I've structured this session is I want you to take you guys from the very beginning, right? So we're at the prompt engineering conference. I thought it made sense to start with prompt engineering, but I'll keep it short. And then we'll go with agents and what agents are, what context engineering means in the context of agents, no pun intended, and finally, strategies for reliability. When we talk about prompts, essentially, prompts are basically just instructions to your LLM, right? You are framing your question or your query in a certain way to get the LLM to say something else, right? So it's the way you ask the question, and that's essentially how we define prompt. So prompt engineering really then is the art of talking to the LLM. The reason I call this an art is because the way you write these queries can be very intuitive. Sometimes you can say a simple thing such as summarize this text and it will work. And sometimes you add a bunch of things and it doesn't work. But essentially, the way you shape your query then defines the way the LLM answers. If you guys want to come, you can sit over here. That's fine. We have some spaces here. Okay. That's fine. You can sit over here.
If I sit down, if I sit truly there,
Okay.
hopefully I won't.
Okay. We can think of like in the early days, right? Developers basically thought of prompt engineering as the clever way of shaping instructions and then getting the LLM to do what they wanted it to do. And if you remember, we had like entire job descriptions coming out for prompt engineers, right? And that's because it's a non-trivial task, I think. It can be iterative and you can really guide the model based on what you add to the prompt. But the issue with this is you typically start off with defining the role of the LLM, right? So in this case, I've said you're an expert technical writer, data scientist, and translator, but then you need to keep adding stuff based on your application, right? And very quickly, you can see that this is mind-boggling for you as an engineer, and then also for the LLM, right? And this is where sometimes we ran into lost in the middle problem as well, where the LLM tends to forget everything that's in the middle of the prompt. I think a good way to think about this. So this guy, Dieter Rams, he's a German industrial engineer, and he has the minimalist. He talks a lot about the minimalist design philosophy, and he says that good design is as little design as possible. And I think that can also apply to prompts and context and the way we talk to the LLM. Right, so this is where context engineering as a term comes in. Instead of adding everything to the prompt, we define pipelines and basically, we define things in particular steps instead of shoving it all in one mega instruction. And the term really gained a lot of traction. This is the CEO of Shopify, Toby, and he said that he liked the term context engineering over prompt engineering because it defines the task of what we want to do, what we want the LLM to do better. And this was a tweet. And in response to this tweet, Andrej Karpathy is like a known voice in the AI space. He replied to this tweet and he agreed. He said, yes, +1 to context engineering over prompt engineering. And you can see that this was very recent. So this is around June of this year. And he says that people associate prompts with what they want the LLM to do. But when you're building applications as a developer, you need to really, there's like a bunch of different things, right? And getting this right is both an art and a science. And there's like multiple steps in this process. So context engineering is the term that gained traction from here, basically, because it defines the core task better, right? It encompasses of a bunch of things now. One, it still has the system prompt, by the way. So how you write the prompt makes a difference. There's then short-term memory and long-term memory, and how you, and we're talking about this a bit because this is really important for agents, right? How you write to memory, how you retrieve from memory. It has retrieval augmented generation, for example, if you have an external database, how do you index things and then how do you retrieve it? We also have tools and function calling and user input, right? What is the user asking? How are they asking it? And some people also say that guardrails is also a part of context engineering, but it's a bit controversial. But I think anything that influences how your LLM is going to give you the output is going to be part of context engineering. Right. So when we talk about agents, it's important to understand what context means for agents, right? So when we started off, this is back in 2022 when ChatGPT came in. ChatGPT is great, right? But a solitary language model is quite limited because it does not have access to external tools. It does not have access to databases. And as a problem solver, you might need all of those things to build your application. We quickly saw that many applications then had a control flow. We had some steps before the LLM call, and then we'd have some steps after the LLM call. And these can be anything, right? This can be retrieval, this can be tool calls. And this is great. This control flow, by the way, is called a chain. You can also call it a workflow. But this is great because these are reliable. So you have the same control flow every time, and you as a developer define what this control flow is, right? But we quickly found out that in some cases, we want the LLM to define the control flow, right, based on the user query. And we don't want to predefine things. And this is essentially in this figure, right? You give it a bunch of steps, and then you have the LLM define what step it wants to take. And this is basically how we define an agent, where the control flow is defined by your LLM. So this is great, but the issue then that comes here is you don't know what the LLM is going to pick, right? And you don't know which step it's going to take. So reliability by default is a problem that agents run into. And when you have some of the issues that we'll see in the next few slides, you'd see that it gets worse because of all of the things that we're doing or expecting with agents. So essentially, agents operate across tools, turns, and memories, and their performance depends on at each step in time. It depends on what they see, what they recall, and what they act upon. And for that reason, context engineering for agents becomes even more critical because this is about then filling the context window of the agents with just the right information at each time. Referencing Karpathy again, he basically defines this in a good way. He says that we can think of the LLMs or the agents as the CPU, right? And your CPU has a RAM, which is limited. And for the LLMs, this would be the context window. So your CPU at any point in time has access to all of these external resources, right? So external tools, software tools, external disk, outside world, right? And just as your operating system defines what enters your RAM of your CPU, we can think of context engineering as the same way, right? So the context engineering then defines what enters into the RAM or the context window of your LLM. Before we talk about some of the issues that agents run into, there's this very interesting dilemma that a lot of us seen. If you see a lot of blog posts or are on LinkedIn a lot, you'd see that a lot of people now think that since we have longer context windows, we can throw everything at the LLM and then the agent should be able to figure it out. And that's because some of the foundation models like Gemini, for example, they have 1 million plus tokens, right? At the beginning of this year, we really saw a decrease in RAG enthusiasm. We saw an increase in MCP hype because the point was that a lot of people made was you could add all of the tools in the world to your agent or to your LLM, and then the LLM should be able to figure it out because it's such a long context window. And it also fueled the enthusiasm for agents, which we're talking about fixing, right? But some of the issues I'll be talking about some of the issues that we run into with even with long context windows. But this graphic that I found online, I'll not take the credit for this, it summarizes it, right? Sometimes having more data just means more chaos, right? So with 1 million contexts, you can see that you have a bunch of laptops and papers on the table, but you don't know where the information is, right? And that's similar to how sometimes it is with LLMs. And typically, we can group agent failure modes into 4 categories. And I think it's important to go through these to really understand how bad it gets when you are building fully autonomous agents for production. The first is context poisoning. So what happens with this is that during the agent's workflow, the hallucinations or errors, they get into the context and they get reinforced by the agent, right? So the agent then confidently repeats this false information. And this was also, I'd encourage everybody to go back and read the technical report of Gemini 2.5 Pro that was released by the DeepMind team. And they had a Gemini agent that was playing Pokemon. And they saw that if a negative or if the goal section of the agent gets poisoned with the wrong context, then the agent keeps trying to play for goals that don't exist. So even if at some point you're trying to reinforce that this is not correct, if the context gets poisoned, then, hard luck. So that's one of the challenge. Context distraction is when you have too much information and that can overwhelm the model. Surprise. Agents can't find the relevant signal in the noise. And this also happens when you have a really large context window, in the case of, for example, Gemini. The third category is context confusion, which is that you have superfluous context that influences the responses of the agent. And the agent then starts to give answers based on the irrelevant information. And an even more insidious type is context clash, when you have different parts of the context that contradict each other. And so your agent doesn't know which is correct, right? This is one of the studies that was very interesting. It's called Less is More, Optimizing Function Calling for LLM Execution on Edge Devices. So one of the tasks really, or one of the experiments that the authors of this paper did, they evaluated the small model. It was the Llama 3.18 billion quantized model on the GeoEngine benchmark. And this trial basically featured 46 tools. So what the team found was that model wasn't able, even with the 16K context window available, the model wasn't able to perform on this benchmark. And when they reduced the number of tools to 19, the model suddenly started to perform, right? So even if your context window is still available and it's not filled, if you have like a bunch of tools, your model can become really confused about what to use, right? So more tools can cause context confusion. So we need to be careful about what we do and how we load all of the tools into the agent or into your pipeline. This is another really interesting paper by a team at Microsoft and Salesforce. It's called LLMs Get Lost in Multi-Turn Conversation. And on the right, you can see that this is a prompt that has all of the instruction. And on the left, you have a sharded version of this, right? So you'd also often see that sometimes you just type everything into your model, everything into ChatGPT, and then hit enter. And sometimes you just give it information along the way while you're interacting with it. So what the team found out was that when they sharded the response, there was a 30% decrease in the model's performance. And they were evaluating on a bunch of benchmarks, but for O3 from OpenAI, the score went from 94, I think, to 64. So and it was similar for a lot of different models. So apparently, if you shard a prompt, this can cause context clash for the LLM. So this is an example of one of the agent failure modes. Effectively, what we can think about then is that Walden Yan is the co-founder of Cognition. This is the team behind Devin. If you remember, this created a lot of hype when it came out. He says that context engineering is really the number one job of engineers that are building AI agents, just because of some of the challenges that we've seen and because it's not straightforward to go about it. So finally, we are on the subject of the session, which is about designing the right context, right? And we can group this into 4 buckets or 4 strategies for reliability. The first one is about writing the context, right? So how do you write the context means where do you save it? We don't want to save everything into the context window of the model because we've seen that can cause issues such as context clash, context confusion. But part of the agent is that it needs to think through things, right? So where do you save this context that can potentially end up harming things? So that's like the first step. The second one is selecting this context, right? So how and from where do you pull relevant information into the context window to help an agent perform a particular task? The third is For fully autonomous agents, as they go through the workflow, the context can end up getting very large, right? This is also one of the problems that we faced when we were designing this memory management system for one of our clients. Long-term memory can get very large very quickly. We have some strategies to compress this context. And finally, we want to isolate context, so we don't run into issues such as context cache. And there's, once again, different strategies, different ways of doing this. So this is pretty much the same version of the first slide, but we'll be discussing some of these things in detail. These are the 4 ways, and then there's strategies for each of them. So the first one is around writing context, right? So I've included 2 things for this. The first is Scratchpad. So you can think of Scratchpads as how you also, when you're as a person taking notes, right? And some of those are rough notes, and you don't want them to end up in your final draft. You can think of that, the same idea for the agent, right? The idea is that we want to save some information outside the context window and then have it be available for the agent for usage during all of its thinking. But we don't want that perhaps to end in the context window of the agent. And that's great. Scratchpad approach is great for within a particular session, but sometimes we want to retrieve or write information across sessions, right? So across many sessions, right? So in that case, we want to retrieve this to memory, and we'll see some of the ways that we can do that. So this is this looks very intimidating, by the way, but I've added this to enforce a point. So I've added that to the list of resources. This is a multi-agent researcher blog by Anthropic. They built a multi-agent research. So if you do deep research in Claude, right? So they outlined some of the strategies and ways that they were doing that. And they have this lead researcher, which is everything that you see in the middle. I don't know where to point this. So this big green thing, right? So this is their iterative research process. And this is the lead researcher then goes to other sub-agents, right? And what they found out was that this is an example of the Scratchpad approach, basically. So all of the stuff that you see here, right, this is not part of the agent's context anymore. This is truncated. Once you get to the 200,000 tokens, it gets truncated. And this is the Scratchpad approach for writing the context, right? So this is the first example of that. The second is around memory, right? Scratchpads are great, once again, if you want to do it for a particular session, but if you want to do it across sessions, then you can also write to memory. And even within a particular session, you don't have to do the Scratchpad approach. You can still write to a database. So the idea is that you have some existing memories. As the new context comes and you update the memory, and then have that be available for your agent to refer throughout the different turns. The second strategy for reliability or for design context for agents that we'll be talking about is around selecting the right context, right? If you've written something to memory, then we need to be able to retrieve that in an effective way, right? A lot of work and research is being done about effective memory retrieval. Okay. If you study RAG, one of the huge things, right, around RAG is effective retrieval, right? So that's like the core piece where things fail very often in RAG. So that's the first thing. The second we'd look at is a strategy called tool loadout. So agents, they use tools, but they can become overloaded if you supply too many tools. So what is a way to do it? We'd look into this. And the third is around knowledge. If you have external databases, how do you retrieve stuff from this effectively? But yeah, if you treat your context like a junk drawer, the junk will influence your response. That's the basic, I think, idea with a lot of stuff around context engineering. When we talk about retrieving from memory, agents can be programmed to select memories specific to the task they're performing, right? So we can group memories together into 3 different things. Anything that's like a fact, we can call that, or we can term that as semantic, right? So if it's relevant to the task, then the agent should just fetch from semantic memories. If this is relevant to what the agent should do, we can group this into episodic memories. And if this is around steering performance, we can group this into procedural memory. Grouping memories grouping conversation points into different memories can help retrieving from the right memory. And you're not at the end, you're not struggling to get, because your long-term memory can get very big and very messy. So it's important to keep it organized. And this is one strategy to do that. Right. Next, we talk about tool loadout. So this is a very interesting paper called RAG MCP. mitigating prompt bloat in LLM tool selection. So I'm not a loadout is like a gaming term apparently, and it refers to the specific combination of abilities, weapons, and equipment that you select for a particular match. I'm not a gaming person, but online this is what I found. And you can apply the same rule to your agents. So the idea is that you only select relevant tool definitions for a particular task. And one of the ways to do this is through RAG. You apply RAG on the descriptions of the tools and then only load tools that are relevant for that particular conversation. And authors of this paper, Gan and Son, this was published in 2025. So when they prompted DeepSeek with beyond 30 tools, the overlapping descriptions that caused confusion, and at more than 100 tools, the model basically failed all of the benchmark tests. They then had a RAG-based selection for tool loadout. So this limited the tools to less than 30 tools. And this kept the prompts concise. They saw that there was a 3 times increase in the accuracy and all of the benchmark metrics when they were using this particular strategy. RAG is one of the ways that you can do it. I'm sure that, that there are other ways. For example, if you know all of the different behavior modes for your agent, then you can just group those together. And then based on the user query, you can judge and load from. So that's also one of the ways. And finally, for knowledge, right, retrieval in RAG, this is like an entire discussion. This could be a conference in itself. But basically, your embedding search, it very quickly becomes unreliable as a retrieval heuristic they're talking about for code base. But basically, the idea is that based on the problem at hand, you can rely on a combination of techniques such as metadata filtering, knowledge graph-based retrieval, re-ranking. So try what works and then use that for your particular problem at hand. And we can now think of summarizing everything that we've talked about so far. So when we talk about selecting the right memory, the first thing is that we want to do is to narrow the scope. So Claude Code, this uses this by having everything in a single file for procedural rules and then referring to that. You can have like different memory types like we talked about. Windsurf, they have this implementation that we just talked about of semantic, episodic, and procedural memory. We also want to index with structure. So ChatGPT, for example, they use knowledge graphs to find semantically relevant memories. You can also have stricter filters. So one of the things that happened, this was at the AI Engineers World Fair. So Simon Wilson, he shared how ChatGPT accidentally retrieved in memory, and then they used it in image prompts. So it's important to have stricter filters. And then if a particular user wants to opt out of using their information, then this should be an option. And finally, we should be able to filter for relevance. Cursor, for example, it only retrieves active project rules from memory rather than the whole thing. And when we talk about filter for relevance, I think it's a good point to segue into the third part, which is compressing the context. We have, once again, 2 ways that we can do this. So agent interactions can quickly get very long and get very big. So summarization is one of the key ways that we can summarize stuff and keep everything in. And then the second way is around trimming. So we can prune the context and we can filter out information that perhaps we don't need. So perhaps filtering out older messages from a list. Out of time or? Okay, I just need a few more minutes. Yeah, okay. Claude Code, it runs auto-compact when you exceed 95% of the context window, and it will summarize the full trajectory. So this is being used in a lot of like production-grade systems now. And when to summarize, these are some of the tips. So you can add summarization nodes deliberately and not everywhere. And you can use domain-specific models where accuracy matters. Finally, we want to isolate the context. We can do this through 3 different ways. The first is by using multi-agent systems, right? So we want to split the context across sub-agents. We can have sandbox environments. And then the final one was maintaining a state, right? OpenAI's SDK library, it offers sub-agent implementation. Google's ADK also does that. So that's one of the ways that you can do this. Anthropic also use sub-agents for isolation of context. And Hugging Face, by the way, also does it. But the issue with this is that multi-agent token usage can become very large, right? So this is a metric for this. So agent token usage, when you compare it to chat, is 4 times, but with multi-agents, it's 15 times, right? So then another strategy is around environment isolation. We have, for example, with code execution, so if your agent is executing code, then we'd like to sandbox everything in a particular environment. So then only the selected information goes back to the LLM. I had finally a demo, so I think that's going to take a few minutes, but I'll just quickly go through the screenshots. Right, these are some practical tips. You have LangGraph, LangMem. You can use reflection or meta prompting to define procedural memory, and then you can also use semantic search using LangGraph's PIC2 library. I'll skip this. The slides will be available, so you can go through this later on. But this is a demo of a multi-agent study partner, right? And it uses some of the context, some of the concepts that we talked about. So the context, for example, is written to and retrieved from the state. This is a scratchpad approach. It doesn't fill the entire context window. Secondly, the context is isolated using summarization. At each, it has a multi-agent setup, and each step, it retrieves information from multiple papers, so it summarizes it. It's not overflowing. And then for isolation, it's using a multi-agent design. And this is the QR code for all of the resources that were referred to in this session. So you can just like scan it, and it should take you to a Google Docs that's available, and you can go through everything. And that's it. Thank you so much, everybody.
Thank you so much. Okay, guys, this was incredible resource. Make sure, oh my God, Jesus. Yeah, make sure to connect the slides, all the resources. Please keep conversation going. This was incredible. Thank you so much. We don't, unfortunately, don't have time for Q&A.
No, it's okay.
It's okay? Coffee place. Okay, we will have our next speaker. And now we're going to go from reliable context to reliable platforms. So while the speaker gets ready and I don't blow everyone's ears, I'm going to try to make an introduction for you guys. So we have Tahreem from Google. And if you build for web, your new AI runtime is browser. So AIs in browser, we heard it, but today we're going to hear from Tahreem, who will show us how Chrome built in APIs and log transcription, image description, translation, and more, and without no heavy infra required.